Okay, can everyone see my screen?
Yes.
Okay, yeah. Give me 1 second. Okay, let's get started. So, hi everyone, welcome to today's lab. Here is today's agenda, and I will first go through the homework 2 solutions and then give an overview of homework 3 and provide some guidance to help you to finish it. So let's first review homework 2. As I can see from your response to the homework 2 survey, I could see a lot of you had trouble to running a server. So I would first like to go through how would you start a server step by step. The easiest way to do that is that if you are using an IDE, say I'm using the VS Code, you can double check if your IDE has the extension to help you to host a local server. So VS Code has this extension called live server. You could find it here. And you can see this extension helps you to start a server simply. Let me just show you how you do it. So I will first open the homework 2 folder. Okay, now you go to your homework 2 HTML file. Maybe this one. Okay. After you install that extension, you just do right click and you will see here is a line said open with live server. You just click it. And then it will start a server for you automatically. So right now there is nothing because I believe I didn't add anything here. So if I'm going to modify this HTML file, I'm going to add a header here, maybe homework 2. And all you need to do, it has like fresh website for you, and you will see your change has already been shown here. So how do you link your JavaScript to this HTML file and to see how you change your code will change this page? Then you go back to your IDE. And here you could say like we've already linked it 3 JavaScript files for you. So you can just open one of them. Let's open the script file and let's do something to say just the console.log to say I am here. And if you go back to your live page, you could say your changes has already been printed out here. So that's how you start a local server, and then you can change your JavaScript file, and everything you changed will like affect this page. But if you are not using an IDE like this, or if your IDE does not have this extension, an alternative way to do that is that you can do it manually. So the first step you do is to open your terminal. Zoom in a little bit. Okay, so if you go to the homework 2 instruction, you would say we provide all the commands you need to host your own server manually. The first step is to change directory. So cd means change directory. You need to change directory to the homework 2 folder. So let's do cd, and you need to type where you put your homework to. Mm. Okay, now I'm already in this homework 2 folder. And the next step, since I'm using Python 3, I will copy this line and just paste it here. Oh, no, I need to change my Python to Python 3. So let me paste this line again. And if you see this line, that means your server has already been started, and you can just copy this link and go to your browser and paste this link and go to that page. You will see this page lists all the files included in this directory. And then I just click the homework 2 HTML file. You will see everything you changed here. That means you have started the server successfully. So the reason we want you to servering a directory is to make sure we are able to access the data files with your JavaScript code. Otherwise, you will not be able to read and use the data in your visualization work. So we will keep asking you to serve your homework directory, since in the later homeworks, you will still need to manipulate and visualize the data. So it is very important for you to know how to actually serve a directory. If you still have trouble with it, just feel free to send me Slack message. Okay, after you have this server started successfully, I would like to go through the homework 2 solutions. So the first part, we want you to do some data wrangling and to create, and within your tree class, we want you to create a list or that is represented by an array of objects of the class node. So I would like to explain a little bit about the class here. If you have not had this object-oriented programming experiment, you might get confused about what the class actually do. So actually, a class is a template that for you to creating objects. And as you can see here, within each class, you would be able to manage your variables and functions easily, and you could and as long as you link your JavaScript file to the HTML file, you will be able to use any class that inside any of the JavaScript code file. So it is very convenient for you to manage your variables and functions. So to first create a list of node objects, you need to know how to define a node object. So since we've already defined this node object in this node file here, you just need to call this class name in your tree script. So the way you define a new node is to add a new here and add the class name, which is node here. And you need to put the two parameters you need to create this object. So if you go back to this node.js, you will see this class requires two parameters. The first one is the node name, and the second one is the parent name. All this information has already been stored in this data file. So in this tree script, the JSON is the data that passed to this class. If you go back to the script file, you would see we read this tree.json in, and then we create a new tree object and we pass the data to this tree object. So in your tree script, the JSON here will be exactly the same data contained in this tree.json file. So you can see this is a list of directories. So for each directory here, it has two components. The first one is the name. The second one is parent. So you just need to pass these two components to this node object, and it will help you to create a list of node object here. So if I print out the nodes list here, and go back to solution. And you could see this command gives you the list of nodes that printed here, and you could see each element is actually an object, a node object, and with two attributes. The first one is a name, the second one is called root, and the other attribute you need to build use your in these functions later. Okay, so the second step is you need to assign the parent node to each node object. So within this list, for each node, you will need to double check that if your node's name equals to okay, so here you need to do like a loop inside this large loop. So for each node, you need to go through the node list again to find if one node has the name equals to this node's parent's name, you will assign this node's parent's node to this node n. And what it gives you will be this attribute called parent node. You can see now for each node, you have its node name and parent's name and the parent's node. Then you can go to the next step and build your tree structure. So after you have this node list, the next step is to complete the build tree function here. This function will use the list you just created and add a link to the node's children. So the way you do it is that you need go through the node list, and if you print every node, you will see here is how your node looks like, and then you will go through another loop to assign the current node to its parent node. After you have the children list for each node, the second thing is that you need to assign levels and positions to each node. So I believe this is the most difficult part for this homework, because you need to write recursive functions to assign levels and positions to each node. If you go back to see the structure here, or if you can see the coordinates figures here, you could say the levels represent the first coordinate here. It represents from left to right what position your current node is, and the position node represent the second coordinate here. It represents from top to bottom what position your current node is. So let's start with this assign level function. Within this recursive function, I would like to let you look at the most right node, because it does not have any children here. So the first thing you do is you assign the level parameter you passed in each assign level function to this node level. And if this node has any children, you will do for each of his children, this n will equals to this level, the nth level will equals to your current node's level plus 1. So if your node is the root node, you will first assign the level 0 here. So we always started from the root node, and you will assign 0 to its level. And then for this root node, you will go to its children, and for each of his children, you will do this function again. So for example, we will go to its first children here, and for this node, his level would be 0 plus 1, which is 1. So in this way, you assign the first coordinate to this this node. So, and you just need to do this recursively. It will assign all the levels to your tree nodes. And the idea is quite similar for this assign position node. The only thing is that for this position, you need to pay attention that if you need to like record for like for this node, root node's children, if you go to the second children here, you need to record the position of the first node. So the first children of this parent node's position would be 2, not 0. So this is the only thing you need to pay attention to. And after you assign the level and position to each node, the next step is to render the tree. So for rendering the tree, you will need to use the SVG element, you first append an SVG element to the body, and then you append the circles and lines to the SVG element, and also the text element. So this part is kind of straightforward. In this line, you append the SVG, and you will need to we set the width and height value for you, so you don't need to change this part. And to render the edges, you just bind the data to this line elements, and you assign the attributes of the coordinates to each line. And to render the nodes as well as the text, you first need to append a group element. So the best way to do that is you create a group variable and you bind the data to the group element, and then you do a translate to put all the group elements in the right position, and then you draw circles and you draw text within the group. In this way, you will not need to assign the coordinates to the circles and text again, because you have already do the translate here. So finally, the tree would be looks like this.
Excuse me.
Yep.
Is this solution going to be visible to us after the tutorial today?
Yeah, I think this will be published.
Thank you.
Mm-hmm. Oh yeah, here I put the I also put a link to the live server extension. So if you go to this slide, you will see how to install the live server extension. Now let's go to homework 3. So different from homework 2, in homework 3, you will be asked to create more interactivity for your realization. To do that, the first step we would like you to do is you need to create basic events so that you add function to your staircase button and select menu and the random subset checkbox. So let me open the homework 3 folder. Oh, this is not correct. No. Double check that. This is how your homework 3 HTML file originally looks like. And the first step you need to do is you need to write this staircase function to make the left part of this bar chart to arrange into this stair-like shape. In this part, we ask you to only use JavaScript and DOM API and not these three yet. In the third part, you need to draw each of these charts. For the bar charts, line charts, area charts, and scatter plot, you need to bend the data that the data we have already read into the JavaScript for you. You just need to use the data and to create each of this chart. And then we would like you to do some interactivity. The first interactivity is you need to update this select menu here. So if you select another data set, it will update to the corresponding charts that reflect that data set. We have an extra credit here to say that instead of just dumping the coordinates to the, oh, sorry, I skipped something. So for the scatter plot, in addition to draw it to the interface, you also need to print out the X and Y coordinates to the console. So in your console, it will show like, it will print out here, like when you click on a point, it will show you like the X and Y values of it. So we give an extra credit here to say that instead of print them out in the console, you could also like add a tooltip which demonstrate the coordinates when you put your mouse hovering on each of the points here. And then we would like you to implement the function for the checkbox. That means when you click on this checkbox, it will take a random subset of this data set and will draw only that part of the data. Here is another extra credit that means you could add any transitions. So instead of like draw the updated chart directly, you could like this, no, not this. If you see here, so the data will change slowly to the new data set. And finally, your homework should look like this, but you are free to change like the styling of it and maybe the scale of each chart. That is okay. And since for the first part, we ask you to use only the DOM API and not D3, you need to use this like document that get element by ID to get each of the rectangles you need, and you just add the attributes like what is the length of each bar by using this part of the code. And the D3 part you can use the D3 part like later, like as long as you finish the first part. So here is more about how you do DOM API. And I will explain a little bit about the D3 scale. So the scale is a function that takes input with a specified domain. and also a range and produced it takes the input of a specific domain and output a specified range. So the domain refers to the original data you have. So it is the range of your data file, and the range is the range of the output. So the actually width and height you would like your elements to be. So you will use this D3 scale to transfer your original data to the actual length that will displayed in the interface. But in this homework, we has already provided these scale functions to you, so you just need to use them. And the way to use them is that, for example, if you want to attach an attribute called X to some elements you select, you just call this scale function and put the data value as the input, and it will output a range value for you that you can use to actually draw this element. You can find more information of the scale here. And for this D3 generator, we will use the line generator for you to create this line chart as well as this area chart. So we provided one of the generator examples in the script.js for you. And for it has two attributes here for X and Y. You just put, you need to specify which value you would like to use as X and which value you would like to use as Y, and it will generate a path for you automatically that you can use to draw the line charts and area charts. So now I would like to go to the observable and to explain more about the updates and the interactivity.
Where can we find these slides?
I will put this after this lab.
Okay, thank you.
Will they be on the GitHub page or somewhere else?
I'm not sure yet, but I will let you know like through the Slack announcement.
Okay, thanks.
So I think last lab we have already gone through a little bit about the D3 updates, the enter, X, and merge. Since you will use them to create the interactive visualization in homework 3, I would like to review it again and dig a little more into what's going on under the hood. So let's look at a simple example with an SVG here, with an SVG containing 3 small rectangles. And here is how this SVG originally looks like. You will see it has an ID called mySVG, and it contains 3 rectangle elements here with height equals 10 and width equals 50. Now we would like to select all the rectangles in this SVG. So we first select this SVG by its ID, and then we select all the rectangles inside of it, and we print this selection out. This will be how it looks like in your console. Can you see it? Okay, you will see it has 2 parts here. In the group parts, it contains the 3 rectangle elements. And in the parent part, it contains the array of its parents. Here it is the SVG element. Within each of the rectangle elements, you can also see the data bound to each rectangle. And now we would like to bind a new data list to the exact same selection. You could see here that the data array contains 5 values. However, we only have 3 rectangles. So let's see what will happen if we bind this data to the same selection. You can see there are 2 more arrays here. One is called enter and another is called exit. If you expand the enter array, you will see the first 3 elements are blank and there are 2 placeholders here. And if you expand the group array, you will see the first 3 is the original rectangle elements with 2 more empty elements. So if we find this enter selection here, you could see the groups become this enter array here. So this is a new selection that you select a group of elements with the first 3 is blank and 2 more placeholders. If you do append rectangle, you could see the empty element remains blank, but the last 2 elements are replaced by these SVG rectangle elements. And let's take a look at the exit array. So you can see in the exit array, there are only 3 blank elements. This is because we do not actually have any elements to remove at this moment. However, if we reduce the length of our data sets, for example, the original selection contains 3 rectangles, while the length of our data array is only 2, we would say these blank spaces and we would say this exiting array contains some placeholder that represents to the element we are going to remove. And finally, we can use this merge command to get a union of the group and the enter array. If we recall the elements in these 2 arrays, you will find for the entry, the first 3 is empty, and for the group, the last 2 are empty. So in this merged array, you will find that anywhere there is a blank in one array, there is a rectangle element in the other, and as a result, this merged selection returns an array that contains rectangle elements for each of our data values. And the new data values has already been bound to each element. And here we can see an animation of how this process actually looks like. If I do update, it will create an enter and exit array, but nothing will happen to the groups array. If I do enter, it will create 2 more place hold here. And if I do exit, nothing will happen. And if I do merge, it will combine what contains in the group array and in the enter array, and then give you 5 rectangle elements here, and its length is corresponding to the data values. And you could, after this lab, you could add this data array yourself and to see what will happen if you use different data for this part. And I will skip this exercise. The next part is how do we enabling interactivity. So here we will see a simple example that we will using this array to create interactive activities for this circle element. The first step is you need to select the SVG and to select the circle. So now you have this circle element here. The next step is to add attributes to this circle. You add the x coordinate, the y coordinate, and the radius, and the color, and the stroke color, and all these attributes to this circle. So now, how do we add interactivity for it? Here we would like to add some events that when my mouse hovering on this circle, the color of this circle will change, and the width of this stroke will also become thicker. So we first do on mouse over, and you create a function. The D here is the data bound to each circle, and the I is just the index of each circle. And when you hovering on each circle, you select that circle and change the color and the stroke width of it. And when your mouse is out of this circle, you change everything back to the original. So the final results will be looks like this. And then we will compare the style method and this attribute method. So the difference is that the style method calls the update inlines of your CSS style. So it will affect the CSS styling in your HTML file. But the attributes method will only reflect the SVG element attributes. So it will not affect the CSS styling. And if you are going to change the attributes, here is the for a circle. Here are 4 different attributes that you could change, and you can see style is like one of the attributes within this list. And if you do circle styling, this is how you will style your circle, you will do that all in a line and separate them with this. Okay, so how do we set listeners and handling events on your selections? The basic method for doing this is to use this on function. So the basic grammar for this listener is to first select some elements and add this on function here, and you will specify the type name and then the listener function you would like to use for this event. And here is a list of all the event types here. You can see there's a lot. And for each event, a listener is a function. So for each element of the selection, the listener will pass the associated data and also the index to this function. And you can do any updates for your selected elements inside this function. In our previous example, we did two events. The first one is mouse over and another is mouse out. And here is an exercise for you so that you can write your own code to change the interactivity here. And I think that's everything for today's lab. Do you have any questions? So I will use the last 10 minutes to answer questions. If you do not have a question, you can leave now.
Thank you.
I have a question for part 1 of homework 3.
Mm-hmm.
Yeah, does it matter how we do it? Do we edit like the HTML directly, or do we add an event listener for clicks or change? Or
What do you mean by like change the HTML file?
yeah, because in HTML you could add the tags like on click equals some function or something like that.
Yeah, I think the best way is that you do that in the JavaScript file and you link that function to the HTML file. So you don't like write function in the HTML file.
Yeah, okay, perfect.
Yeah.
Thank you.
No problem. I think we do not accept homework that is late for more than 2 days. So we gave a 2-day extension for this homework, but I don't think we will accept more homework after since I have already shown the solutions to you. So how do we link the JavaScript function to the HTML file? You don't need to link the HTML function. You link the you link the JavaScript files to the HTML file, as we did in homework 2, and then everything you changed within that JavaScript file will affect the HTML page. No, actually it's still due on Friday, but we just removed the late penalty for Saturday and Sunday because the wine, the wind and everything went last week. Mm-hmm.
And so for the grading part,
Mm-hmm.
if we have like done the functionality of the program, like the coding, but we are using like different ways to do it, are we like getting like reduced credit for that, or?
It is no matter like how you do that, as long as it is not hard coding or something like that, it should be fine.
Okay, thanks.
Hey, I have a question. I think we just talked about it, but the homework assignment is still due this Friday, right?
Yes.
And there is no extension, or there's no like extension for that, like the last homework. It's just the penalty applies after Friday, right? Still
Yeah.
for homework 3, right?
Yes.
Okay. All right. Just making sure.
No problem.
Okay. Thank you.
Hi, Michael. Do you have any question? If not, I'm going to close this meeting.